Hello, dear participants of the EuroSciPy. My name is Pavel. I'm today's chairman. I hope you had a good lunch. Did you have a good lunch?
Yes.
And now there will be a talk by Norby about data processing on microcontrollers with MicroPython. Please.
Thank you so much. Let's see. Can you hear me okay?
Yes.
Yeah, great. So thanks for coming here and listening a bit about hardware and physical computation with Python. I think it's the only talk that is very related to this. If you find this interesting, there will be a little sprint hosted on Friday where you can get to play with these things yourself with MicroPython running on small hardware. I bought a little kit, and if a lot of people show up, we'll do some pairing and then you can play with this stuff. My name is Yoon. I work for a company called Sound Sensing. We monitor ventilation systems in commercial buildings like this, make sure that the operations teams are notified if there's anything weird happening. And we use Python on the back end. We use Python for, of course, machine learning and analyzing data. And we also use Python on small microcontrollers to prototype new sensor solutions. And the goal of this talk is that you, as a scientist or engineer that is supporting scientists, you become familiar in how to create custom sensor systems using microcontrollers and MicroPython, including a little bit more advanced things like on-sensor data processing with digital signal processing or machine learning. And I say familiar because I cannot teach you all of these things in 25 minutes, but we will cover a little bit about wireless sensor networks. We'll cover MicroPython, a Python that runs on microcontrollers, and we'll cover the EMLearn machine learning library for microcontrollers that I maintain. So, wireless sensor networks. What are they, and why are we interested? So, for scientific applications, we want to understand the world. And in order to do that in a good way, it's very useful to measure it, to collect data that is relevant for the phenomena or the challenges that we are trying to understand. And in many such situations, it is very beneficial to be able to measure over time. It's very beneficial to be able to measure not at a single measurement point, but many measurement points. If you want to understand how noise in a city, it doesn't make that much sense if you only have, or you cannot do much if you only have a single sensor. But if you have a lot of them, you can understand much more broadly. And if you can correlate that with other data, you can start to build a solid understanding. And if you want to understand, for example, how water flows in order to, for example, prevent or detect flooding risk or hydropower potential, this kind of things, you also want to measure not the water at a single point only, but you want to measure across a whole system, potentially a whole country. And it's in these cases. Because you want to measure it over time in many measurement locations, you need something that is quite low cost. I mean, the lower cost you can do with the same budget, you can have more measurement points, right? You want to have something that works unattended. You don't want to go and sit and measure every single place. And you need some way to get the data into your where you're going to process it, where you're going to analyze it. And sometimes you also want this system to be small or portable. If you want to understand how animals behave by having sensors on them and understand their motion and behavior and dynamics or across migrations and so on, you need to be able to place a sensor on the bird. So that means that you are interested in doing this often with wireless communication, battery powered. Then you need to use microcontroller, so it's low power, and you want to use as much as you can, use off-the-shelf commercial sensors. For example, MEMS microphones or MEMS accelerometers have been popularized via mobile phones, and that is now incredibly good sensors for incredibly low prices with incredible power efficiency that you can use for scientific applications. And you want to do some smart on-sensor processing sometimes, and I will show you why, and especially to optimize energy, because lower energy means you can have a longer battery life, or a small battery. So these kind of systems are composed, like simply put, you have some sort of sensors, depending on your task. You have some sort of microcontroller system that you do your processing, so this is running in some software. And you have some sort of connectivity, or you're acting on that data and the information that you have analyzed. It's often wireless. And we will focus here on the processing part. This is not a hardware talk. And if you do this, if you are able to, for example, do machine learning there on the sensor, inference of machine learning model, you can have things that operate standalone. They can be privacy compatible. You can do low cost and so on. So this is the type of systems that we're talking about. So just briefly, the microcontroller, modern microcontroller is basically a full little computer. It's very power efficient and affordable. And these days they're relatively powerful. I mean, they have over a megabyte of RAM for a few dollars. So that's, by historical standards, amazingly powerful. They often have built-in connectivity. Here's just one example. So this you can start to treat them as small little computers, and that's where something high level like Python can be very, very useful. So if we're measuring some slow changing phenomena, like the water in a river, it doesn't change much, second by second, or at least that's not what we're interested in. We can do this quite simply. You can have a measurement kind of loop where you sample your sensor and you process this data a little bit. Maybe you just do a median filter or something to reject some outliers. It's very simple things. And then you send the data over some wireless protocol. And then you'll put the system to sleep for usually many minutes, and you'll do the same thing again. And this works, it's quite simple, and it works well when you have this slow changing phenomenon. And this can be very power efficient. And the longer you can sleep, basically, the more power efficient you are. And this works well for some things like temperature or something that we don't need to measure continuously. You can do samples every n minutes, and that's appropriate for the application and data quality you want. But if you want to track the activity of an animal, that is more of you might want to know, basically at any time, what is the animal doing. And there's one project from a master student that's for tracking health of cows. We're using an accelerometer, and there the cow might not be always moving, but you don't know that a priori, so you need to measure all the time. So then in red, you measure all the time, but they're very power efficient, so that doesn't take all your budget. In these systems, it's usually the transmission, the sending of data, that is the most power intense. So if you would take the accelerometer data, that's maybe 100 hertz, 6,000 kilobytes per minute. If you would measure it continuously and then send that raw data continuously, you would spend quite a lot of energy, or you would spend basically all the energy sending that data, because you're sending all of it. If instead you do some simple machine learning, for example, he used a decision tree to classify the data, a little bit pre-processing, classify the data into some classes, for example, lying, standing, grazing, things that you're interested in tracking. You can get that down to, you can do the sending much more seldom, because you have much less data to send. And that means you can spend much more time sleeping, or at least your transmitter is not active. This saves a lot of time. So you can do a lot of compute per byte sent. So it's a good trade-off in that if you can save some 100 bytes of data per minute, you can run a full neural network, this kind of thing, in that same, or in actually a smaller amount of energy. So this is the motivation for doing machine learning in this type of systems, basically power saving. At least that's one main motivation. There are other cases. So this is a project for vaccinating Tasmanian devils. They unfortunately are threatened because there's some tumor growth that is very dangerous. So they're trying to vaccinate them, but they're all over the place. So there's an autonomous system that has vaccines, or food with vaccine in them. This is like in really very rural areas, like miles and miles to any people. This system has a camera, actually has a trigger, a PR sensor, like similar to a security system. Wakes up the system, then they takes a picture, so that if there's any activity, it could be human or some other mammal or just wind or something, that triggers the system. You take a picture, and you find out, okay, is this a Tasmanian devil? If so, if we classify it as that, then it will dispense a bait, because we want to vaccinate the devils and not all the other mammals that are interested in this food stuff, right? Or birds or whatever. So in this case, we're acting completely locally, and this wouldn't be possible if we didn't do the machine learning there, because the connectivity, it can send events to track that's things that happen, but it's not a reliable connection that you could, for example, like send this to the cloud, then get like, oh yeah, it's a Tasmanian devil, go back. Even if you would kind of have enough power, it wouldn't be reliable in these rural settings. So that's another case. And then you might be interested, okay, how could I do this? The tradition in in microcontroller land is that, yeah, you write all your code in C, don't even use C++, that's like too modern, that's like the traditional. But because these systems are getting more powerful, we're getting better software, you can now do basically this in Python. So there is an implementation of Python called MicroPython. It's been around for almost 10 years now. That implements a subset of Python 3 for devices that have at least like 128 kilobytes of RAM. It supports a bunch of microcontroller families and also supports you running on top of Sapphire, which supports like almost everything in the world. That's a Linux Foundation project. So this is a great way to use your existing Python skills into this domain, which might be new to you, or you might be not an expert on that, but you can bridge across by leaning on things that you know. So it's very easy to install. You usually download a pre-built firmware. For most boards, you can do that. There's the tool for flashing it, like programming the device, is available at least for ESP32 in BIP, so that's super nice. There's a tool for connecting to your device over USB. I can also do over Bluetooth or Wi-Fi. And then you get a shell on your little microcontroller. A device like this that costs maybe like $10 or something. Or even smaller if you're just on the bare chip. Then you can go down to like $1. It is a completely independent Python implementation, so similar to something like PyPy. It doesn't share any code with CPython, and also the domain is quite different. So it has a high degree of compatibility with CPython, but it's not 100%. Because CPython is developing, there's some obscure and very advanced features that it doesn't implement, but you will find it a very, very, very familiar environment. But notably, the C API is not the same as on CPython. So that means no NumPy, no pandas, no scikit-learn, no TensorFlow, etc. Directly. But there is another C API, and there are alternatives to many of these softwares that are, it's not just a limitation in terms of compatibility of API, but also these devices have typically 1 megabyte of RAM. If you have, it will not be possible. You cannot even load the CPython interpreter in 1 megabyte of RAM, and NumPy and pandas and so on. Often you're at 100 megabytes just importing the module. So even if you had compatibility, it wouldn't work. So there are some known ways documented. There's some things that are not implemented. There's references for that. But what MicroPython has in addition is a machine module, which is related to how you would access all these peripherals, as they call it, things. Functionality that is about communicating with the real world on such a device. So there's also a machine module, and it also has a bunch of connectivity options, because these devices often have either built-in connectivity, or on the board you have a kind of core module that will give you connectivity. So there's Wi-Fi, Ethernet, we can do the usual kind of HTTP or MQTT type communication. There's also Bluetooth Low Energy, which is excellent for sensors with like a 10-20 meter type range. You can do cellular, so it can be like as a mobile phone. It's not the most power efficient, but it's very convenient. There's cellular connectivity all over the urban world, at least. And in the rural setting, or if you want really long range for low power, there's something called LoRaWAN, which is really one of the best switched to that. And that's also well supported. It comes with battery included. It also follows kind of the Python ethos. There's a file system, which is not really typical to have built in on these microcontrollers. So you can store files. You can put some NumPy array there. You can have a CSV. You can do these things as if it's a little computer, which it basically is. And there's a tool for connecting to the device, which also then allows you to, for example, copy scripts back and forth. You can also trigger running some MicroPython code from your computer, so that it's really convenient when you're iterating quickly. And there is a package manager called NIP, so it's separate from PyPI and etc. But you can do the similar type of things. You can install, from a package index spanner. You can install from a GitHub repository, or you can also run, if you have Wi-Fi, you can run it directly on the device. So these top commands I would run from my laptop, but this one you could run directly on the device. It can also install native C modules at runtime. And this is a really unique feature in this embedded space. So usually you can, if you have there's some JavaScript implementations, etc. for microcontrollers, but they usually cannot install native C modules at runtime. But MicroPython can, which is a really cool feature and super useful for data science machine learning. So, Python as a language is not the fastest thing in the world. And this, on the desktop, is usually not a big problem. On the hardware, that can be more painful. You want to have this energy efficiency. You don't have that much capacity in general, so you need to kind of make use of what you have. It's like 1/1000th of the power of your mobile phone, so it matters. But there's some really good tools in MicroPython. There's a number of JIT-style decorators that will actually compile. It runs on the device, which is amazing. Just as is possible, and will compile a small function and apply extra optimization, and uses type hinting to do that. So that's really cool. There are two flavors of that with different kind of pros and cons, or flexibility versus performance. There's an inline assembler, which is also really cool. So the assembler itself runs on the device, and you can write Python, but they are the statements that you have. They are actually assembly statements. And you can have C modules, which you can install at runtime. So a lot of really good tools, so that it's not just a solution that that's convenient for simple scripting. You can really make powerful and professional grade production systems with this by careful use of these to manage performance. So and we did a talk on PyData South Africa about this. It goes a bit more in detail. It's on YouTube. Just a little bit about C modules. So this is how a C module, very simple one, would look. You basically write the whole module in C, and then you do these declarations in order to basically inform the runtime what is a function and what's the function called, etc., which is enough to make this into a Python module. So this is so you're kind of doing the implementation and the bindings in one step. And there's compared to CPython, there's a very small data science ecosystem, but there is a start of the data science ecosystem. So we have things like OpenMV, which is inspired by OpenCV for computer vision, very focused on that. There's ULab, which is like micro lab, that implements a very large part of the NumPy API, completely from scratch and targeting this environment. And then there's EMLearn MicroPython, which implements pieces of scikit-learn, SciPy, etc., for the machine learning and DSP parts. And they are not necessarily. So ULab is very compatible with just the API directly. The other ones are more, you could say, inspired by and make sure that they are conceptually compatible. So it's easier to transfer your skill sets. So EMLearn for MicroPython. It's really about how can we enable people that know Python to do machine learning on these devices. So you can do these kind of advanced systems without it needing to be super difficult. So there are two parts, because when we talk machine learning on device, it is 99% of the time it's inference, which means that we train using a regular pipeline on our computer, using our regular tools, scikit-learn, keras, etc. And then inlearn provides some tools that allows you to export that trained Python model into a optimized C-compatible model. And then we have a runtime, or not really, sometimes just code generation that you can have on the device. You can use C, you can use it on the C library level, or you can use it with the MicroPython bindings. It supports the regular tasks that are relevant for sensor data cases. It's distributed as a set of independent modules, and they try to be very, conceptually very similar to what you are used to, and also, so there's a function that allows you to take a random forest classifier, one-liner, and then convert it into something that can be loaded by this on-device runtime. And so we do some machine learning parts, and a few of them can also do a bit of training on the device. And then also some DSP. I found that to be very useful for pre-processing of sensor data. So how it looks in practice, you do your regular training loop, you convert it, you save it to the tree models, can be saved to like a CSV type file. You can then pay remote to copy it to your device. You will need to make sure to have the library installed, so you do that with a MIP. And on the device side, you can import the module. So this is implemented in C, but it has a Python API, so it is a Python module. You can instantiate it, load the weights or the decision nodes of a tree, for example, and then you would integrate this into your application. So you would read data from a sensor, you would maybe do some pre-processing on it, do a prediction with the model, and then use that for something. Either it's triggering the release of a bait to a Tasmanian devil, or it's just sending that little piece of data now onwards in an efficient manner. So there's a bunch of examples in the repository for quite practical oriented tasks, including some examples of training loops and data collection, all the things that you need around. So you'll find those in the link in the repository. That's all we have. So to summarize, in many scientific applications, we are interested in collecting quite a lot of physical data, usually over time, and having many measurement data points. And these large deployments are made possible usually by low-cost wireless sensor networks. Such sensor network nodes can be developed in Python by using MicroPython on the microcontroller. And MicroPython has a lot of good tools for this use case, for sensor data processing, including connectivity, storage, and tools for making it efficient and performant. There is a start of an ecosystem for data processing type tasks, including machine learning with EMLearn MicroPython. So again, I remind you that there will be a sprint on Friday. So if you're interested in joining and coming and play with this, and this is completely open for newbies and just curious. I know that most of you probably don't have any prior exposure to MicroPython, so this is a chance to get it. And that's all. Thank you.
Thank you for your talk about MicroPython. Please ask your questions.
Thanks for a great talk. What are the times for these devices? How long can they survive without being recharged? Weeks, months, years, something like that?
You can do, like on a coin cell battery, for several cases, you can do 2 years.
2 years.
Yeah, so multi-year is often what you want, but it's not always possible. If you want to have a camera, that takes a lot of energy, so then we might be talking weeks or months. But yeah, multi-year for simple measurements is possible.
I was curious about the use of cellular network for communication. So, like, do you need a SIM for it? What can you do with it? Kind of like you went through it very quickly, but
yeah. So cellular, you could. I mean, conceptually, you can do everything that you can do with your phone. Conceptually, the modems are similar, but you need a SIM, but there is now also a thing called eSIM, so which is not a. I'm sorry. Can you hear me? Yes. Okay. Nothing broke. You can with the eSIM you don't need a physical one. You can kind of program in which SIM is this. That's the trend for modern things. But yeah, a lot of our devices have a SIM in it, so you manage that. And there's cellular providers that specialize in what's called machine-to-machine communication. So they, like a SIM is not related to a person; it's related to a device, and they will offer you packages. You can do it in how many thousand do you want? They will devices basically. So, and it's quite a lot cheap compared to the SIM that you have in your phone.
Can you also store the data locally using like an SD card or something? I could imagine that it might happen in these projects that at some point you realize, oh, we should have used like a different kind of model to analyze the data on the machine, and then you still would want access to the raw data.
Yeah, it's a good point. Many times you will sample some raw data. So you might have a strategy where you sample regularly on time, or maybe like you do a percentage, or maybe you do some smarter things like the things that the model is unsure about, we will collect it with that. Yeah, and you might store that on an SD card. That also takes a considerable amount of energy, so you need to budget that in. And then you might pick up the devices, every couple of months, and you have a selection of raw data there as well. And that is a very tricky consideration, like not just having the final deployed system, but also something there where you can debug, you can improve the models. Because with machine learning, weird things happen, like more common than uncommon.
I have a question about what is the benefits of using MicroPython compared to C. So I guess if previously people for years have done it in C, there should be some infrastructure, some libraries for machine learning, or some lightweight machine learning algorithms in C, and what benefits MicroPython provides if we still have to develop this ecosystem, we cannot use the existing ecosystem.
Yeah. With the MicroPython, because you can bind C modules, you can kind of use the existing C ecosystem, right? You just need a little bit of work to expose it, but that's quite doable. But of course, MicroPython is the same, you could say, conceptual benefit as on a desktop. You can operate in a higher level language. Automated testing, for example, is much better. So it's much more nice to do automated tests in Python compared to in C. That's something I really like. You have high-level facilities like a file system just built in, connectivity. In the IoT, you're often dealing with network type protocols, right? Which might be text-based or binary-based and so on. And doing that in C is very, it's very prone to bugs. It's very tricky, that kind of stuff. So that, for example, if you would do that in Python, that's much more, it's safer and saves you from a lot of obscure bugs. Like the network bugs are bad enough on your computer. When you have thousands of remote devices and occasional bugs there, that is very, very, very painful. So, and you get a REPL, right? So you can actually remote shell into your device, for example. So you have powerful high-level facilities that can really help you develop faster, and I would say in many cases build more robust systems.
And what is the overhead for keeping the interpreter on the? So you should have the interpreter on the device.
Yes.
So what is the? And you should load the RAM, I guess, or not?
RAM?
Yeah.
So there's a starting point. Like you can MicroPython will need before you're doing anything useful, MicroPython, the interpreter, will take up quite a lot. So I would say that you would budget maybe half a megabyte of flash memory for that. So it's mostly useful if you have one megabyte of flash or a couple, and then you would budget at least 120 kilobytes of RAM. So that's like things that you kind of lose because you have this overhead. So as long as that is acceptable, the things that slow in MicroPython is things that have to do with allocations. So you want to keep that low in terms of runtime overhead, and that's where it's useful to use all these tricks that I mentioned. But you can, I mean, if you do like with the pandas and numpy, etc. If you chain through those in your program, your execution time is 99% of the time inside there. And then same here, if you do that style, you'll have very close to the same efficiency.
Thank you so much for your talk. If you have more questions, you can come on Friday for the sprint and get much more about using MicroPython for microcontrollers instead of C.
Yeah. Thank you.
Yes, great. What's your name?
Loic.
And surname?
Esther. Yes.
Esther.
Yeah.
Good. What you talk about?
PyPy downloads. PyPy downloads.
Yes, it's right. Do you need water? So use it. As a microphone. So you can put into your pocket, I think it will work the best. Yeah.
Like this. It's not working. But I don't see the
Currently we need to share this. Do you want to share full screen?
I see it. That works successfully.
I have instruction just to press this button, but no, it doesn't work.
So I see it now. HDM1. So before it wasn't seen it.
So you see it, but it doesn't see you. What if you press F7?
F7, I'm not sure what that does.
I always press this button.
Yeah.
For,
but that's Linux, I'm not sure.
Oh, I also have Linux, but
I never
to change the mode.
Generally, I do that.
What is that
It's
program?
but that's what they did before when I see it. Now I see it.
Just a minute, sir. And they concentrate. See?
Great. What?
So your better button presser. Is that working or not?
Indispensable. You have to press a button.
Is the mic working, you think? Or
So,
I need to
can
turn
I
it on.
see? I don't know, was it turned off? Yes.
Okay.
The next talk will be presented by Lawyer Castev. It will be about PyPI.
So I am Loic Esteve, and I'm going to talk to you about some surprises I discovered when looking a bit in more details about PyPI download stats. So about me, shortly, I did a PhD in particle physics. My main achievement during my PhD was to measure a cos and a sine with an experimental error of 0.8. So as you may know, there's a strong theoretical constraint that is between -1 and 1, so I didn't revolutionize particle physics, it's fair to say. But particle physics is hard to revolutionize. You need a lot of people for a long time to actually learn something new. So I went to work in finance. I did as much C++ I could, a little C++ I could, and as much as Python. And then I ended up in EuroSciPy, which is a research center in France, where I was very lucky to be paid to work on open source, mostly scikit-learn, and a few packages around it, like JobLib, and also I was involved in Dask and PyLive. And 1 year ago, I joined Probable, which is a company which is trying to pay people to maintain open source software and also make enough money to pay them, and find some business around open source software. Okay, so PyPI in the face, explaining the joke so that it's over, get it over with. So if you look at some plots of the number of downloads for scikit-learn, it will look like this. So there's a period at the beginning in 2016 or something until July 2018 where the data is a bit weird, so you can forget about it. But afterwards, it kind of grows up, and if you're a scikit-learn maintainer, you feel good about it because, of course, it means that okay, people are using your software. You're not working for just without any users. So that's nice. You can look at the numbers; they're very big, and you feel very good about it. 3 billion downloads. I think if you were to look at this plot today, 100 million download amounts. That's great, right? But the reality is, each time I look a bit more than this kind of plot, looking at what the data is like, basically, yeah, that's what happened to me. I got pie in my face, more surprises, and more caveats. Right? So I'm going to describe a bit what I discovered. Because I feel it's not something actually I found like some blog post about it, about everything I discovered when I submitted this talk. So I want to talk a bit about that. So the first caveat that basically you can find on the PA user guide. Basically, they will tell you, okay, this data is not necessarily super useful, and also it's like highly inaccurate. So one of the first reasons is when you do pip install, basically you have a local cache, and basically if it's the same scikit-learn version, the same Python version, you can scikit-learn cases with spatial, you have compiled code, then you will download it once, and if you redo pip install many times, you will actually count only on one in the download stats. So if you wipe your cache, then you will count another time. You will count as another normal. So a normal user, basically, you do pip install 1, and then that's it. You do pip install, you download once, and then you don't count anymore in the stats. So there is a bias towards automated, probably, as I learned, as we'll see later, there's a bias towards automated use case where you don't have a pip cache and you download each time you launch your CI or you launch your automation. And also there's something that's this page describes. It's PyPI mirrors. So as a company, I'm not exactly sure how it works, but basically you can have a PyPI mirror because, for example, for security you want to control it, or for compliance or this kind of thing, or you want to have also your own package that are uploaded to the same PyPI index. And that means that these mirrors are going to download the package from PyPI, and they're going to increase your download counts. Okay. So that's the general thing. And but the first caveat, if you're like, okay, you're a maintainer, your package is not, it's not getting used, it's not like NumPy or SciPy or these main packages, and you want to know, okay, is my package taking off? Do I get some traction? Or this kind of thing. And the first caveat, if you look at the raw numbers, is basically most downloads are not from pip install. So this is a case where in Probable we're developing Score. So this is an open source package. This is supposed to help you compute metrics, do diagnostic plots around scikit-learn. And basically, if you were to look in March, for example, and you look at the installer type, so this data, the raw DB is on Google BigQuery, and you can look at this. And for example, in March 2025, you would see that actually the installer type is bundle snatch. So that's the mirror mentioning request. So that means that some people are doing request get on the PyPI for whatever reason. And then if you go down, then basically you will get some UV and pip. You will get some browser, so it's like probably browser automation, I don't know, where people are downloading from the PyPI with the browser. And also you get now whatever this means. Probably people doing wget on your to download your wheel. If you look like more recently, actually nowadays, like Score is more like PP and UV has increased and the other less. But basically, if you look at your raw number, you think, okay, I'm getting downloaded maybe like 2,000 times per month, but among the 2,000 times, like you have like 1,500 which are not actually people doing pip install. So that's probably the first thing you want to look at if you want to have an idea about how many people are doing pip install. And also between different websites. So the raw database is on Google BigQuery. So it's a bit annoying because you have a free quota of 1 terabyte and you need to write some SQL stuff. So that's a bit annoying. But you have also websites, and for example, one is pypistats.org, which gives you like high-level plots. And between, for example, pypistats.org and like another one that's called pp.tech, you will get different numbers of number of downloads. And one of the main reasons, in my opinion, is because they don't treat the same, they don't filter the same way on the installer type. So pypistats.org will keep only pip because it's more representative of real user downloading your package. And the other, they don't really care, so you get the whole number, and it's probably an increased number, which makes you feel good, but it's not really representative of user installing your package. Okay, if we switch to scikit-learn, basically, when you look at this download stat, you shouldn't think of them as like a real person doing pip install, because the numbers are not on the same scale. So basically, if you look at the website statistics, you have 1 million roughly unique monthly visitors. And PyPI stats, you have like 100 more times. So it's not the same user downloading your package 100 times per month. That's not reasonable. Another thing that doesn't really fit is that on the website, like 60% of the users are on Windows. And if you look at the PyPI stats, you will get this, and then basically it's more like 90+% are from Linux OS. So that doesn't really fit. And you have like interesting things as well. That, for example, if you look at so this one is from clickhouse.com. Then basically the most downloaded release, so that was from a few months ago, is 1.0.2. That was released like 4 years ago on Christmas, so it's probably why it's the most downloaded release. It was a Christmas present from Guillaume, who's in the audience. And basically, if you click on it, you will see that most of this is downloaded. If you look at the Python version for the 1.02 release, you will realize that most of them are 3.7. And as a reminder, like 3.7 was end of life, like into June 2023. So but it's still it was the last release that supported 3.7. So I guess there are a lot of people caring about 3.7 in the world, more than we think. And actually, there's a CPython developer, Hugo van Karamade, who had a blog post about it. I discovered it more recently. And basically, the BigQuery dataset has the Linux distribution information. And then you will realize that there's a lot of the 3.7 download that comes from a distribution that's called Amazon Linux 2, and where you have Python 2 by default, but you can install Python 3 if you really want, and you get Python 3.7. And so if you look at, so there was the query run in May, so basically 30% of all scikit-learn download on the particular day came from Amazon Linux 2 distribution, and more if you look at other Amazon Linux. There's another one that's called Amazon Linux 2023. Okay. So that was to say that, okay, there are interesting patterns in this data. This is not like who come from cloud use case. And basically that means that they're using some old Python version that we don't really support anymore. But there's also an interesting pattern in which, for me, is like a bit the deal breaker, is that, okay, scikit-learn dependent joblib, so that's one of the dependency. So you would expect naively that if math makes sense a little bit, that joblib is downloaded more than scikit-learn, right? And actually, if you look, so there was the data from May 2025, actually joblib is downloaded less than scikit-learn, which to me doesn't make more sense. So if I'm trying to come up with nice stories to explain this, what possible explanation? Is it because joblib is released less recently than scikit-learn, so that means that it's more likely to be cached? It is a cache thing that you use system joblib, so you don't download it from PyPI, but you use scikit-learn because you want a more recent version. I mean, it's a bit of a mystery to me. Okay. So that was this for scikit-learn. Next story is sklearn. So you may not know this, but basically at one point you could do so you can it's pip install scikit-learn. That's the name of the project scikit-learn, but you do install sklearn, and there's an easy confusion to make that why not you do pip install sklearn, right? And actually it worked for some time because we didn't want another package to take the name and upload some malicious thing there. So it was a combination of convenience plus avoiding malicious actor using this package. But at one point we decided to stop doing it. So there was a brownout over 1 year where you would get an error during some specific time periods. And this time period will be longer and longer, so you will be more likely to discover that there will be an issue. And then you have an escape mechanism through an environment variable, because we would expect that a lot of packages depend on sklearn, and we don't want to break everybody basically without an escape mechanism. So we had an attempt to disable the cache to allow this brownout to be effective. But that was too naive, so we reverted it, and basically what we did is that we released one sklearn version, 0.0.3 in March, 0.0.5 in May, and this kind of thing, so that people would now know the new version, and you will get a new error, and you will raise awareness of the issue. So I guess the idea was, okay, we can look at IPI download stat and see whether the brownout is actually working and people are moving away from this sklearn package. So the reality is, in Cyan over there, that's the latest release, but it's still downloaded quite a lot. So on this particular day, it was 30K times per day. The 0.0 is the first version that was from a while ago, so it's still working. And then the interesting pattern is that you have plenty of this transition release between post 3579 that are downloaded almost all the same. Basically, there's a 3K times per day that people download this thing that error with a probability of some probability. So it doesn't really make sense who is downloading this intermediary release doesn't make much sense. And if you look actually at the installer type for this, you would expect, okay, maybe it's some mirroring stuff, but actually the installer type for this is mostly pip. So there are some people or some automation or whatever in the world that are downloading this completely useless transition release for no particular good reason. At least I don't have any. Right. There is also so Boto 3 is downloaded a lot. Basically, it's released every day, so I guess this is the reason why it's downloaded so many times. It's automation, and you have the same pattern where Boto 3 depends on Boto Core, but Boto Core is downloaded twice as less as Boto 3. So it's not only in scikit-learn world that you have this pattern, you have this pattern in other places, and it doesn't make sense to me why Boto Core would be likely to be cached more than Boto 3, so another place where it's weird. And another thing was just to say that it's so easy to misinterpret this number. You could look at the download stat of 6. So if you were lucky not to be around for the Python 2 to 3 transition, 6 is something that was helping you to both support 2 and 3 at the same time. And it's in the top 20, in most of them packaged in 25, so 2025. So 15 years after like the Python 2.7 end of life, it's still like super at the top. And you could easily misinterpret it as like, oh yeah, people do still care about Python 2. But actually it's more than one package in particular, Python Daitutil, is used quite a bit in pandas, Boto 3 and everything, and it still depends on 6 because the maintainer has other priority than removing the 6 dependency, which is completely understandable. Okay. For a long time, I thought, oh, maybe it's probably the CI that is doing the install, and it's not like real humans. And you actually have some thing in the BigQuery DB that can help you. It's based on environment variable, so it doesn't have full coverage, but maybe it can give you an idea. But actually, if you look at this, for scikit-learn, it's only 10 or 15% of the download that comes from that have this field which is set to true. So it's probably too low to explain all the download. But at this point, I'm more convinced by the cloud use case. So everything I learned, basically, installer type is important if you want to have more accurate number for like new or upcoming packages. In scikit-learn case, it's even influenced by cloud workflows. The thing that depends here are less downloaded than dependence. Honestly, I have no explanation for this. Yeah. Okay, so that was the easy part where I talk about the factual thing I discovered, and then there's the more hand-wavy and vague part where I'm going to have to represent you Aveck thought about metrics. So with this metric, basically, I feel like they are of too big importance, and we actually, when we look into the data, we forget like all the caveats at the end of the data. And one of the things that I think is important, but that I think we're all aware of, is that when a metric is a target, then people will chase the target, and then it will lose its value, basically. Okay, and then not everything that can be counted counts, and not everything that counts can be counted, and apparently it's not Albert Einstein that said this, somebody else, whoever this is. I agree with him. Okay, so in the grand scheme of things, okay, I agree that basically PyPI is one source of data. It's kind of a proxy metrics. It gives you an idea whether you're popular, whatever popular means, and maybe there's some signal in it, but we don't really know how to extract the signal. And it's the case for other metrics as well. And I think, like, basically, generally what happens is you have an opinion, and you're like, okay, it's just an opinion, so I need to find some data to back it up. And you find some data to back it up, and now you feel like it's a lot stronger. But then once you find the data that match your opinion, then basically you forget about it, and you move on. And I wish there was some kind of, political fact-checking scale where basically you would kind of be able to indicate whether some statements with these metrics is mostly true, mostly false, or pants on fire. And in my opinion, like there's a lot of these statements that are pants on fire, but maybe my detector is miscalibrated a little bit on this. Okay. So personally, this is my opinion. I think if you need like to say, okay, my package is important for funding agency, for investors, to have money to pay someone to develop it for grants. Sure, I mean like use these numbers, they're big, they make you look good. Go ahead. If you want also to gauge like whether there are more packages that provide free-threaded wheels, or that have PyProject.tom or this kind of thing. Please look at all the top downloaded packages to have some idea about how the ecosystem is moving. If you want to take it as a general trend to see whether your package is taking off, why not? Honestly, for me, it's a bit you have no idea whether there's some automation somewhere that was kicked off and that started downloading packages automatically, or whether it's a real thing, but why not? And then if you start to want to compare two packages to saying, oh, this is getting more traction than this one, this package is getting more traction than this one, I think in my opinion, because of the job dependency versus dependent thing, that dependencies are downloaded less, I think you're in very murky territory. I wouldn't do it personally. So for example, polars versus pandas, I mean, if you start looking at PyPy download stats and to say, okay, polars is getting a lot more popular than pandas, I don't think it's a good way to do it. And if you think you have a good explanation for why the data is behaving this way, I think it's probably an oversimplification. But maybe you have a way better crystal ball than me. But I wouldn't do it like that. And in the end, I know basically, I'm the grumpy person on the left who said, no, you shouldn't do that. And people are more interested in looking at PyPy stats and other metrics that go up and that make them look good. And I agree that sometimes you should do that. But I tried a little bit to document the thing that the caveat I discovered along the way. So this is the conclusion. Honestly, I don't really understand the reality that the PyPI download metric describe. There are many caveats, as I said. In scikit-learn case, it's likely heavily based by cloud workflow, AWS in particular. Maybe, just maybe, we should refrain from making too bold claims based on PyPI data. And I wish, using proxy metrics and telling stories, why not? But maybe it'd be nice if the people making this claim were more clear with their intent and confidence level. So, maybe it could be an explanation rather than, okay, this is the explanation, look at the data that backs it up. And that's it for me. Thanks a lot.
Thank you, Loic. Are there questions?
You could add another possible reason why all of this number don't make sense. I think in the last 3 years, the bots training LLMs are devouring the internet, right? Downloading random stuff from different IPs so that you cannot block them. So that is another possibility.
Yeah, they would download, do you think they would download wheel in particular?
Random things.
Okay.
Everything, right? So they're stupid, you just don't load anything.
Maybe, I don't know. I'm just wondering whether there is a way to know from the data, but I don't think. The user, the installer type, I guess, it tells you a little bit because it tells you which tool actually you use to download the package. So would they use pip just to I don't know. But it's easily playable. I mean, these metrics you could do.
They were completely fucked up before LLM. So this joblib scikit-learn problem, it was always the case.
Yes, also that's a good point. That I think this inversion of dependency download, it's still the case. 5 years ago.
On one slide you filtered out, or some way you determined whether it was a CI download or not.
Is it
transmitted in the header fields in the request? Or
so where is that? So there is a field in the DB, and from what I looked at, it's based on the environment variable where you do the download, basically. So if some CI have like specific environment variable like CI, for example, or build something for Azure, and I think that's what it's based on. So when you do pip, so it's only pip. So when you do pip, then pip will look at the existing environment variable, and if there are some that are using CI, they will say, okay, that's come from CI. So they will send it to the Google BigQuery, whatever, and then this will be in the BigQuery data.
Thanks.
But I think it's very partial information. I mean, for example, if you're inside a Docker image in your CI, then you don't necessarily have all the CI environment variables, so it's very partial. But
I have a question about the can you tell if you have a direct install, something that would type pip install the scikit-learn, or if pip is triggered as a dependency?
Yeah, no, I don't think you can. Yeah, it'd be interesting to see if it's explicitly mentioned in the. Yeah, I don't think you can. Yeah.
Do you have any idea how to explain like massive spikes? So, like back when I worked on the moment, I think it was a Sunday, so definitely something about in October. Like on average, it's like a couple of hundred a day, and there's just one random day where we have 7,000.
Yeah.
And
So I know that, for example, like Guillaume, one of my colleagues was here, like send me someone on Twitter that said, oh, any idea? Because like the same, like the PI stats, like plot was going up, and I quickly looked at it, and it was like coming from, it was not pip, basically. The installer type was not pip. So what did that? I have no idea, but it's probably some, automation thing that decided, or maybe a bot gone crazy. I have no idea, but yeah. So that's the first thing I would look at, whether it's installer type, whether it's pip or not. But that doesn't give you the full explanation that what is doing that. It's
the next question.
If you go back to the slide with the AWS packages, for example.
This one?
The one with photo.
Oh, the one with Goto, yeah. Sorry. This one.
So I could see ways that this could happen. Like, for example, when you're trying to install something and you have a version constraint, people will start downloading versions one by one until they find something that puts the fits, and it can happen. But what if you look at the conda statistics, which do not share the same problems, would that perhaps be more reliable than people?
So what you're saying is somebody mentioned this to me as well, that sometimes like the pip resolver is going into whatever mode, like backtracking mode, I don't remember the term, but and start downloading a lot of different versions. But why would it happen? It's not clear to me why it would happen a lot more for Boto Core than for Boto 3, for example. And then your next thing was about using Conda downloads. Is that I'm not sure what you're...
Yeah, so Conda doesn't have the same problem.
So Conda downloads, so I don't remember, there's not a, so I think it's on anaconda.org, you can find some numbers, but I don't think there's a REST API or something like that to give you, but yeah. Or like, it's not in a single database like the Google BigQuery one, but that would be something interesting.
Actually, on the website for Conda, if you look for a package, it shows you the downloads right there.
But also given like is it by day basically, like, or is it the full? Yeah, so it's a lot less detailed than basically the PyPI. But yeah, that could be an interesting thing to see whether the inversion is not there.
Lloyd, thank you for your talk. Hi, what's your talk about?
Industrial documentation for scientific processes.
Yes, what's your name? Revati. Good. I'll present you. So, this is microphone. So, I turn it on. Or you can turn it on when we start. Yes. Yes, we start in 2 minutes.
You have to stand exactly here. Yes. Can you go away?
Yeah. Okay, thank you.
I see.
Thanks, by the way.
You still have 4 minutes before beginning.
Actually, yes, I'm ready.
Huh?
It's 2:40, right?
Yes,
but I'm
2:40.
ready. I'm ready.
Oh. Well, maybe some people will come, some people will leave before that. Thank you.
Okay,
Do you need some water?
no.
Huh?
No, thank you. Will this work? Okay.
I think
No, this one. To change the slide. No, it's okay.
I think it will work if you use this USB stick.
Oh.
But
No,
I don't
okay.
see any connectors.
No, it's okay. I can use this one.
Oh, this will work. Let's check. Ah, here is adapter.
Okay, good. What do you connect to?
Oh, allow.
You want to have this one?
Just quit, because it is not keyboard.
Oh, okay. Oh, it's okay.
Okay, just use the main button, Revati.
Thank you.
The next talk will be presented by Revati about the industrial level documentation for scientific projects.
Thank you. Thank you. Before starting, a little bit about myself. I'm Revati Venugopal, working as R&D in ANSYS. I'm based on Lyon, France. You can find this presentation in this QR code if you want to. And in this entire presentation, you might heard PyAnswers. So before starting the presentation, I would like to give an overview of PyAnswers also. So PyAnswers is an ecosystem that have more than 50 libraries, Python libraries, that have the capabilities of answer simulations. It's Python plus answers. That's it, PyAnswers. So I work for PyAnswers specifically. As I mentioned, we have more than 50 libraries, so it's like industrial level documentation. And we had many challenges when we start writing documentation for those 50 libraries, more than 50 libraries. And of course, first one is having a unified user experience across these 50 libraries, like one person going to one library and going to another library should not have two user experience, right? And the second one is, it's a huge library. You can see it's a simulation, a Python wrapper for simulation. So APIs are changing dynamically. And also, we don't want our developers and users to dig through the documentation deeply without understanding a not proper layout and structure. And other one is, as I said, the APIs are changing fastly, so that you can see the change log is also changing fastly. So we want to keep a proper template and proper user experience in terms of change log also. And of course, we want to be discovered in Google, and we want to give a better search experience. We solved all these problems, and I'm going to take one by one, like what is the solution, how we solved it, and what is the results. So the first one, to have a unified user experience, we created a theme, and the theme is called AnswersNext theme. As the name suggests, it's a unified theme, so we keep all this layout. You can see there's logo, the template, the navigation, the icons, the cards, footer. All these things are unified across all these libraries. Any libraries inside all these 50 plus libraries have the same layout. And second one, we are providing all the solutions that I'm going to say right now, that we are going to discuss right now, is inside this AnswersNext theme. So if I want to change something on the layout of any of these libraries, I won't go to all these 50 libraries. I'll just go to this AnswersNext theme, and I will change it, and it will be reflected on all these libraries. And as I mentioned, we want to get discovered. So maybe if you search AnswersNext theme, you will be the first one, since we did some discoverability. And second one, about the API documentation. We want to make sure the APIs are up to date. And think about a developer is writing all his code and everything, and after that, sometimes he won't update his documentation at the same time. So manually synchronizing the APIs with source code is first thing, it is lot of time, and second thing, sometimes it is error. And other thing is, it is not a small one code. It will be 10 developers working on the same library that have a lot of changes, and it's a large API, and we want to make sure that the documentation is not overwhelmed and it is properly structured. It should be able to track the differences, like with the previous version and this version. And also we have to make sure that the source code is having this quick reference to the documentation. So for that, what we did is, like it written, we, instead of writing a separate documentation, we did a parsing through the source code. We use some open source libraries also behind the scene. So we parse the source code, and from the doc strings, so you are not writing documentation, from the docstring itself, we are passing the documentation, and then we use Jinja to create template. And with this Jinja template, we are basically aligning how the looks and feel of the documentation. And it is very user-friendly format. That is our solution. And I'm going to show you the output. So you will go to the docstring, you will see what are the sub-packages inside this documentation, and inside this what are the constant sub-packages, sub-modules. And let's go to one of the sub-packages. So inside, let's say circle, and inside this you will see what is the classes, and inside the class you will see what is the methods and properties. There is a direct import link also, and once you click on any of the properties, it will directly take you to the documentation of that property. So this is the final output of our API reference in almost all the libraries. I'm moving to the second problem. We use Synix, and the search experience in the Synix is not really good because first thing, it is so cluttered. You don't know where exactly is this particular keyword is there, and on top of that, it is not search on go basis. Like you have to search the entire thing that you want to get. It is not like you search something and you will get the instance result. You have to have proper keyword and then only you will get the result. So to get a better search experience, we use PyData Synix theme search layout, but we change the backend. We change how it works. So basically what we did is we parse all our documentation, we extract all the sections, chapters, code bases, all those things, and then we created a JSON file, and then we use another open source library called Fuse.js, and it is actually using a fuzzy logic, and then we place the default search bar. The look will be the same, but the experience will be different. So this is our solution and this is our result. So you will search something, you will get the instant result, and if you look on it, you can see like it will show it is inside getting started, it is inside installation. So you'll see where you are searching for, and once you click on it, it will directly take you to the result. And this is the result. And third one is the changelog. Let's say you made something, so you can see like you made some changes, but you forgot to add that you made these changes on the PR or on the documentation. So once you have multiple libraries, and once you have to keep track of what all the changes you have done with the previous release and this release, it was very, very difficult to do it manually. So we want to automate that. On top of that, like all our other issues, we want to make it user-friendly. You want to make a template properly aligned, template that have a link to the PRs that address this particular issue and all. So for that, we again use another open source library called Towntrail, and inside this, instead of creating, we our own creating the templates and the fragments, what we did is we enforce conventional commits. So for example, if you are doing some feature enhancement, you have to use feat that enhancement name. So it will directly go under features, right? It's a feature. For example, if you are doing something on documentation, you are supposed to give a conventional commits of docs or doc so that it will understand that, okay, it's something related to documentation. And then we align it with CI/CD. So once you have a pull request, the actions will create a changelog fragment by itself, and then once we do the release, it will combine all the fragments and write it into a single documentation, and then it will remove all the fragments once the release is over. So this is the workflow that I was explaining, and this is our result. So once you go to release node, you will have, let's say, different tabs. Like for example, on this release, maybe you had like documentation and fixed. And on this tab, you have something added, dependencies and documentation, maintenance, and miscellaneous. So we, based on the conventional commit, we identify which is this, and it has the direct link to the PR. That's it. And third one, the final one is the SEO optimization, especially after LLM. The indexing is very difficult on main search engines because many people are creating a lot of content, and the audacity of the content has to be verified. So also we have multi-versions. We have documentation supporting multi-version, old versions and new versions. So we want to make sure that only the stable versions are indexed. And when somebody searches for PyAnswers, only the stable documentation should be shown for the people who are new to our ecosystem. And we also want to make sure that all the associated files for the search optimization has to be automated. So for that, this is also some kind of tips that we did on our research. So instead of hyphens, we use hyphens instead of underscore when you are writing a file, and the file names of particular documentation should be very, very optimized, like very short and descriptive, so that the URL, let's say I want to create a file, you are not supposed to create a file for the multiple file, like that kind of file name. So you have to create something very, very short and descriptive. And we created sitemap and robot. These two files are required for Google to index your page, and also we use Google Search Console panels for our results and performance analysis. And this is our result. For example, if you search for biomechanical, you will see our page on the first on the result along with the associated site links. So yeah, as a conclusion, in industrial level of documentation, we created a single theme. And we also make sure that all our API references, especially from the developer point of view, user point of view, is very up to date, and we are using single source of truth. And also we automated as much as possible. Also, one more thing we want to share is we always have to evaluate our user experience, and also want to make sure that the documentation is accessible to everybody, irrespective of the condition. And also we have to collect the metrics to evaluate what is like our, let's say in terms of SEO, the SEO is working or not, like search engine optimization is working or not. And that's it. Thank you.
Thank you, Revati. Ask your questions, please.
So thank you very much for the presentation. I think many of the points that you presented, we had this to face them for our scikit-learn, and for some of them we did not have a good solution to improve the scikit-learn website. And in particular, I'm really interested in the Fuse.js integration that you did. Is it open source somewhere?
Yes.
Do you plan to contribute it to maybe as a Sphinx plugin, or directly in Sphinx upstream, maybe because the default search of Sphinx is not as good?
Of course, we can think about. First thing, it is open source and it is MIT license, so you can use all these templates and all our JavaScript, HTML, CSS, anything. So I think integration is going to be easy, especially you are using Unix. Of course, we will think about this. Thank you.
And the change leg too also seems very interesting.
Oh yeah, sure.
Thank you.
More questions? Questions about documentation, how they build their documentation. Maybe you need to build documentation for your project.
Thank you again for the talk. Very nice. About again Fuse.js, I'm curious, like, could you go into a bit more detail about how you prepare the documentation so that it can be indexed for the search?
Yeah. Yeah. We actually parse all our documentation with pure Python. So you have, let's say, your HTML files. So we go through all the content inside HTML and we generated a JSON file, that also with pure Python. So we use a plugin to create the JSON file. Until that, it's all Python and JSON. And after that, Fuse.js is a library that uses JSON file to do the search. So it is just JavaScript, like with Fuse.js as a plugin. And also this index.json file, like this search JSON file is, for the moment, we are deploying our documentation in GitHub pages. So we will just add it in the GitHub pages. So you don't need any backend server or anything. So you keep it inside the GitHub pages and that's it. And if it is, let's say, you are deploying your documentation on Read the Docs or somewhere, so you may have to find like a place to store this JSON file, and that's it.
Thank you.
Some more questions? We still have time.
Thank you for the great presentation. I'm not sure this is a relevant question, but I wonder if you have any advice on internal documentation, where, for example, we do some internal Python projects. Typically, we have it all in the GitHub near the project, in the Markdown files, but also our source of truth is actually Wiki. So, for example, Confluence. I'm not sure if you've seen some approaches where you can combine or sync to the Wiki or something like that.
Yes, actually, yes. Same. We also have some internal documentation, and we actually went to Fuse.js because Fuse.js, as I mentioned, it is like the JSON file is with us. So we are not publishing it any of the outsource or any of the libraries. It's completely with us. So we also had some wiki projects, and from what I know, from my experience, it's just JavaScript. Maybe you have to create the JSON file with Python, and once you have the JSON file, you can easily integrate if you have some JavaScript. Yeah.
Thank you. Do you use software tests in your documentation, like somehow in a way that some of the tests may end up as like worked examples in the docs, or like examples in the docs are like used as tests or something like that?
Actually, for the moment, what we do is we collect all the associated libraries. Let's say we have cards, we have icons. So we keep all the examples in the documentation, and we also do pull request previews, and basically it's manual for the moment. But we would love to do some testing. Maybe that would be our next thing that we'd be doing. But ideally, at least for the moment, what we do is we keep all our components, let's say card, icons, admonitions, also the search one, API. So we keep all our examples in the documentation itself. So whenever we open the PR with PR previews, we identify it, like if working or not. But basically we collect all those things together. Because testing is not really easy, especially with the small components. It's not completely Python. It's Python plus HTML plus CSS plus JavaScript. So you have to find a combined test experience for this, right?
I didn't mean testing your documentation build. I meant if you have like tests for your Python software, can you somehow like you automatically integrate the doc strings in the documentation? Could you also include like some of the Python tests as like examples of how that particular function or whatever could be used?
On the doc strings, yes, you can add examples because we follow NumPy doc strings. So yes, you can.
Thank you so much. Now we have a half-hour break. After that, there will be lightning talks, and after lightning talks, there will be poster session. And at 8 p.m. there will be social event. It's just 5 minutes walking from here if you still don't buy jetons, but you want to participate, buy a ticket and convert tickets to jeton at the entrance.
Where are the lightning talks?
In the main room.
Main room? 138 or?
Yes. Okay, thank you. Thank you. So it's never been a big Is this one biggest? And then, of course, when starting and then
Paris, Brussels, Cambridge, something like that. I can be around 6 weeks. Yeah, that's never actually more. So it's like, you know,
yeah, there are some events which are once for years or once reason. It requires more than 1 year to prepare.
Yeah, you don't need to organize them.
So was it in Cambridge or Oxford? It should be very different.
Most organized by company, but the
It's not only the university dormitory, it's also a lot of companies which surround the university, like
in August, then we get pretty cheap accommodation. For students, they
it's reasonable.
Accommodation we pay pretty expensive. Obviously, we don't make money with the presentation.
start roll out monthly doors, it's maybe more interesting than the background.
Or main entrance where it's written EuroSciPy. Because now people just see that probably you are in your office and you found another white screen.
Yes.